So a quick review of solving exponential equations. One, whenever you see the x in exponent, what you can do as a first step is you can take the log of both sides. Two, then you use your log laws. To get the x out of the exponent. And then 3, we can solve for x. So there's not a lot of time left. I'm going to go through, I've got a bunch of pre-made examples for these three. Well, for the first two actually, and then we'll do the third one together. So I'm going to show them to you. There probably won't be a lot of time to write them all out. So let's see, where do I have them? Here we go. So here's the first one. We had 12 equals 4 to the x. If you take the log of both sides, you'd get log 12 equals log 4 to the x. Then you can use your log law here, and this x can come out in front. So then you get log 12 equals x log 4. In order to get the x by itself, can divide both sides by log 4. So this is a very standard way of doing this kind of question. Once you get your answer, you can store it into your calculator, plug it back into the equation to see if it actually works. Is 4 to the 1.79 equal to 12? And if it is, then you know that you've got it right. So with this one, this is the typical way following the steps. You could also do this first one in other ways, and there's often more than one way to do a question. We could also do this first one by saying, hey, what if I use the definition of a logarithm? My base is 4, my answer is 12, the exponent is x. So if we use the definition of a logarithm, this is equal to log 4 of 12. And if you know how to use your log base on your calculator, you could just write log 4 of 12 into your calculator, and you get 1.79 as well. But typically, we're going to solve things this way, using those steps that we had, because those steps will be the same steps you can use in every log equation. Now for the second one, again, this is what it looks like if you take the log of both sides. Now in the work here, you could do one extra step. So you could have a step in here where you just show I took log of 36 equals, and I took log of 3 times 2 to the x plus 1. So just the basic step, taking the log of both sides. Now, you're going to be tempted on the right-hand side to bring that x plus 1 in front. But you can't do that yet. The reason you can't do that yet is because that exponent of x plus 1 is just to the 2. It's not also to the 3. So you have to use the log law first that says there's multiplication in between these. And so I can write it as log 3 plus log 2 of x plus 1. Then that x plus 1 can come out in front as it is right here. Move the log 3 over to the other side. Log 2 is a number, so it can be distributed on the right-hand side here. And you get x log 2 plus log 2. Move all your logs to one side, and then divide by log 2. And you end up with a lot of logs in the question, but when you plug it into your calculator later, that is the right answer. So this is following the steps. Take the log of both sides, apply all your log laws to get that x out of the exponent, solve for x, get your answer, and check it. Now, this is an equation. And equations follow the same equation rules that you have done your entire life. What you do to one side, you do to the other side. That's why when you take the log of one side, you have to take the log of the other side. So another way to do this question would be right at the beginning to say, I don't like this 3 in front. It's 3 times 2 to the x plus 1. What's the opposite of multiplying by 3? Divide by 3. So if you divided by 3 on both sides first, can you see that you would get 12? And now the question is 12 equals 2 to the x plus 1. The nice thing about doing this as a starting point is that when you take the log of both sides, you don't have to worry about this law right here where you have to add first before you can take the exponent out because you're multiplying. That's already been taken out of this, and then you can just bring the x plus 1 out in front, distribute, multiply, and when you show the work on this one, do you see how many fewer logs you have to write? So that makes this nicer in that way. But again, you get the same answer, and when you check that, it works out. So we're going to do the third one here together. This is the one where there's an x on both sides. So we've got 3 to the x plus 1 equals 6 to the x. Again, we can take the log of both sides. And you can take the log or you can take the natural log of both sides. Would it bug you if I took the natural log of both sides? Are you okay with it? Because it saves you 1 letter every time you have to write. It's like a tiny millisecond times. You know, it has to be logs. Yeah, okay. Okay, I could do, okay. If you did natural logs, everything would be exactly the same. We just get to go home earlier because we'd save about 5 milliseconds. So we've taken the log of both sides. The exponent is to the entire base, so you can bring that exponent out in front. And when we distribute, we'll get x log 3 plus log 3 equals x log 6. Now, if you've solved equations before that had more than one x and you were solving for x, you got your x's all on one side. So we'll do the same thing here. I'm going to subtract, forgot the 6. I'm going to subtract the x log 3 on both sides. That gets my x's on the same side. And in order to get a single x, since there's an x in common in both of those, you can factor it out. And then once it's factored out, divide both sides. Go to our calculator to check. So we have, I'm going to use my fraction button, log 3 divided by log 6 minus log 3. And then again, once we've got our answer, so x is approximately 1.58. Once we've got our answer, we can store that answer as x, and we can check if our original equation, the left-hand side is equal to the right-hand side. So the left is 3 to the power x plus 1. Push enter. The right is 6 to the power x. And since those answers are identical, we know that we're right. Questions you can do on these ones, 7, 8, 10, and 12.